Okay, hello everyone. I welcomes to all in our lecture series on laser physics. In this lecture series, we are discussing these topics, which are most essential for B.sc, B.Tech, M.sc, M.Tech, and various entrance examinations. In our last classes, we discussed these topics. Okay, last class we discussed the rate equation of two-level laser system. In this class, we are going to discuss rate equation of three-level laser system. Okay, so let us start. In our previous classes already we have been discussed these things. Okay, you go through this. I suggest that before you have to go through this today's topic, at least you go through this topic, Einstein's A and B coefficients, and you should familiar with this term, this one, rate rate of stimulated absorption represented by gamma STA is equal to B1 to N1 U mu, and rate of spontaneous emission gamma SPE is represented as T21N2. Here T21 represents probability of spontaneous emission, which is the sum of A21 plus S21. A21 represents radiative transition and S stands for non-radiative transition. And rate of stimulated emission gamma STE, the value will be B21 N2 U mu, where B21 is your probability of stimulated emission or Einstein's coefficient of stimulated emission. Here U mu represents here energy density per unit frequency range of pumping system or energy provided from the outside. These three terms about rate of stimulated absorption, rate of spontaneous emission, rate of stimulated emission you should know to follow today's topic. Okay. Okay. So these things already we have been discussed. Last class we discussed this one, rate equation of two-level system. This much, up to this much we have been discussed, and we found in two-level system laser action could not possible. In today class we are going to discuss three rate equation of three-level laser system. Okay. Okay. Discussing about three-level laser system, consider a three-level system here. E1 is your ground state, E3 excited state, and E2 is the metastable state. So here three-level system having three energy levels. Okay. Okay. Here laser action to be found between metastable state and ground state, E2 and E1. B13, B12 represents the coefficient of stimulated absorption from level 1 to 3 and 1 to 2 respectively. B31 and B21 represents the coefficient of stimulated emission from level 3 to 1 and 2 to 1 respectively. Here 1 to 3 means from this to this, 1 to 2 means this level to this level. Okay. Here T31, T32, T21 represents the coefficient of spontaneous emission or probability of spontaneous emission from level 3 to 1, 2 to 1, 3 to 2 and 2 to 1 respectively, where T represents both radiative transition plus non-radiative transition. Suppose a system or a transition have only non-radiative transition, then instead of T we have to write S. If the system have the transition, spontaneous transition, only radiative transition, then we have to write instead of T as A. But if the transition have both from one level to, suppose I am going to consider from 3 to 2, both radiative and non-radiative transition is there, so we have to write T. If only radiative transition happens from 3 to 2, then we have to write A. Instead of T, we have to write A. For non-radiative, instead of T, we have to write S. Okay. Here N1, N2, N3 are the number of atoms or molecules per unit volume in level 1, 2 and 3 respectively, or you can say concentration of atoms or molecules in level 1, 2 and 3 respectively. So total number of atoms or molecules per unit volume is represented, if represented n, so obviously n will be equal to sum of these three, n1 plus n2 plus n3. Here we have to find out minimum condition for the laser action. In this three level laser system, we have to find out the minimum condition. What will the minimum condition for laser action, or the so-called population inversion in between E2 to E1. To find the population inversion, consider the rate equation of various levels. So to find minimum condition or population inversion, we have to analyze the rate equation of these three levels. Then we can evaluate what will be the minimum condition. Okay, first we are going to analyze the rate of change of atom or molecules of level 3, or rate equation of level 3. Level 3 means this one. Okay, here N3 represents at a particular time concentration of the atoms and molecules of level 3. See, this N3 will increase if this stimulated emission will increase. Here for first I am going to explain over here. For energy level 3, what are the transitions, or what are the, yes, what are the transitions? Transitions are stimulated absorption. That means with pumping, uh, the atoms or molecules move from 1 to direct 3. This is called the stimulated absorption. So for this process, the number of atoms or N3 will increase. Concentration of atoms or molecules in energy level 3 will increase due to stimulated absorption process. Another process we can expect, this one, the red one represents your stimulated emission. Due to stimulated emission, transition happens. Atoms and molecules transit from E3 to E1. That means due to this process, N3 will decrease. Another process we can expect, spontaneous emission from E3 to E2. That means transition from E3 to E1. Due to this process, what will happen? N3 will decrease. Another transition here from E3 to E2, that is your spontaneous emission. Due to this spontaneous emission also N3 will decrease. So these are the four process, 1, 2, 3, 4 process that we can expect for level 3. So the change of N3 with time, or the rate of change of N3 with time, is equal to this one, plus B13N1 U mu, which represents the rate equation due to stimulated absorption, or it can be represented by WPN1. Here WP is nothing but B13 into U mu, or this is also called as, here I written, a pumping rate. WP is the pumping rate from level 1 to level 3, and this term will be positive because due to stimulated absorption, N3 increases. Next, stimulated emission. The rate of stimulated emission from E3 to E1 will be equal to B31 N3 U mu. Okay, already we have been discussed in our previous classes that for the stimulated case, we need this energy density term. That means for stimulated emission or absorption, rate of stimulated absorption or emission depends on the energy density, but for spontaneous case, it does not depends upon the energy density. So I suggest that you go through the previous video. Okay. Now another transition, that is your spontaneous emission from E3 to E1. So rate of spontaneous emission from E3 to E1, how we are going to write? T31 into N3. Rate of spontaneous emission from E3 to E2, this one will be written as T32 into N3. Let this is your equation number 1. So this is the general expression of rate equation of N3 in 3-level Levger system. Right? Right. Now here T31 could not be considered. This is the representation. This T31 represents the probability of, here I written T31 is the represents the probability of spontaneous emission from level 3 to 1. So if this term we are going to consider, then whatever the atoms or molecules will be formed from ground level to upper level, they all will be transit to ground level due to this process. So we could not get any type of ledger action if we are going to consider this term. So only for that we consider that this is negligible. The transition, spontaneous transition from E3 to E1 is negligible. So only for that this term we are not going to we are not going to consider for equation number 1, right? And already we discussed that for degenerate case, non-degenerate case, B13 equal to B31. So here B31 can be written as B13. Now the equation number 1 will be written as here dN3 by dt equal to B13N1 u mu already is there. Okay, minus, instead of B31 we can write B13N3 u mu, and this term we not consider, this term cancelled out, and here this term is 0, and this term T32N3 is written as A32 plus S32N3, because we know that T is the total spontaneous transition is the sum of radiative and non-radiative transition. So A written for radiative, S represents the non-radiative transition, spontaneous, right? But here transition from E3 to E2, E3 to E2 always first non-radiative transition, because E2 is the metastable state, so A32 could not be considered. Here you can see the level 2 is very close to the E3. So whatever the atoms will be pumped to the upper energy level, they are suddenly transit to this level by radiating some non-radiative transition. That means we can say they will radiate some heat and they transit to this state, non-radiative transition. Okay, by providing some heat energy, they transit to E2 after 10 to the minus 8 seconds, the so-called natural process, or we can say spontaneous emission. So here non-radiative transition happens E3 to E2. That means here A32 not to be considered. So this term will be represented only by S32. So the above equation will be B13N1 u mu minus this term minus S32N3. Okay. Now consider B13 u mu equal to WP, which represents the pumping rate from level 1 to level 3. That implies this equation will be modified as dN3 by dt equal to, here this one is written as WP, so WP into N1, this term will be written as WP into N3, as such this term are written as such. At steady state this value equal to 0, because at equilibrium state or steady state N3 is a constant value. Hence, the rate of change of N3 will be equal to 0. That implies 0 equal to these three terms I written as such. That implies WP_N3 plus, here these two terms taken this side, WP_N3 plus S32N3 equal to WP_N1. That implies N3 equal to WP N1 by WP plus S32. Let this is your equation number 2. Now we are going to consider the rate equation of level 2, or rate of change of atoms or molecules or electrons of level 2. So here, what are the transitions linked with this energy level E2? Here you can see these are the transitions. This one, this one, this one, and this one. This is your due to spontaneous emission from E3 to E2. This is due to stimulated absorption from E1 to E2. This is due to this transition due to spontaneous emission, this transition due to stimulated emission. Here you can see due to these three transitions, this one and this one, N2 will increase. Sorry, I, sorry. Here, due to this transition and this transition, the N2 will increases because the atoms or molecules coming to this state due to spontaneous emission from E3 to E2 and due to stimulated absorption from E1 to E2, the atoms or molecules for E2 increases. So these two processes we can write as positive. But due to these transitions, N2 will decreases. So these processes will be written as negative value, right? So here, rate of change of or rate equation of level 2 is your dN2 by dt will be equal to T32 into N3. This one, this is the positive value because due to this N2 increases. Again, plus B1 to N1 u mu, also positive. This represents the stimulated absorption part, so only for that it is positive. This represents spontaneous emission from 2 to 1, this one. So it is minus T to 1 into N2. This is your stimulated emission from E2 to E1, due to which N2 also decreases. So only for that this term also negative, right? Here, E3 to E2 always fast non-radiative transition from E3 to E2, always fast non-radiative transition. So here T32 will be written as non-radiative transition means S32, right? I written over here. E2 to E1 to E1 always radiative transition. So that means I am telling about spontaneous transition, spontaneous emission. So whatever the emission, spontaneous emission from E3 to E2 is non-radiative. So instead of T32, we have to write S32. Spontaneous emission from E2 to E1 always radiative. So instead of T21, here we have to write A21, right? And B12 equal to B21. So here B121 can be written as B12. And here we considered B12 u mu equal to W1. So here B12 u mu will be written as W1, B12 B21 equal to B12. So B21 or B12 into u mu equal to W1. So equation number 3 will be rewritten as dN2 by dt equal to this T32 will be written as S32 N3 plus this one. This term will be written as W1 N1. This term will be written as A21 N2. This term written as W1 N2. Right? Okay. But at steady state or equilibrium state, we know N2 is a constant value. So dN2 by dt will be equal to 0, right? So this will be equal to 0 at steady state. So at steady state, these four terms will be equal to 0. So that implies 0 equal to these four terms. Now we have to put N3 value from equation number 2, this value. Okay. WP_N1 by WP plus S32. Here WP represents pumping rate from level 1 to level 3. W1 represents also pumping rate but from level 1 to level 2. You have to remember. Okay, now we have to put the N3 value from equation number 2. This equation will be written as this one. Okay, we just substituted S3 value, this one, sorry, N3 value. That implies here these two terms taken this side, left hand side, W1 N2 plus A21 N2 equal to W1 N1, this one, plus this term written as such. Here N2 taken common from these two terms, so N2 into W1 plus A21 equal to WN1 W1 N1 plus S32 into WP N1 by WP plus S32. That implies N2 will be equal to, this term will be divided with this term and this term, or this term divided with the whole of these two terms written like this. Okay, we just added these two terms, so WP plus S32 will be multiplied with this term plus S32 WP_N1 by WP S32. Already this term is there, so in the denominator we have to write this one W1 A21 and this term WP S32. Here when I will be multiplied with this term with this one, we can found what W1 N1 into WP S32 plus S32 WP N1, right? So here from these two terms, here W1, here we can get these three terms W1 N1 WP plus W1 N1 S32 plus S32 WP N1, right? So here W1 taken common from these two terms, so we can get WP plus S32 WP plus S32, and here this term is your S32 WP. N1 is the common for these three terms, so it is written outside the bracket. Simple addition. Okay. That implies here N1 will be divided with this N2, so N2 by N1 we can found this much, right? This is your equation number 4. So here in equation number 4, left hand side I just subtracted 1, right hand side also subtracted 1. Then I simplified. Here in left hand side it will be N2 minus N1 by N1 is equal to, here this term as such I written here, this one you can see, minus 1 means this one will be written minus of these two terms, by these two terms. Simple subtraction. Now we are going to go for the simplification. Here W1 WP, W1 into S32, S32 WP already there. Multiply these two terms, we can get W1 WP minus W1 S32 minus A21 WP minus A21 S32. Okay, that implies N2 minus N1 by N2. Here you can see these two terms, two terms will got cancelled. W1 into WP, here minus W1 WP, these two terms, here plus W1 S32, here minus W1 S32. So these terms will be cancelled out. Rest terms are this one S32 WP minus A21 WP minus A21 S32 by these two terms. This is your equation number 5. Now by considering equation number 4, so this is the equation number 4 here. The equation number 4 represents N2 by N1 equal to this term by this term. Okay, so by considering equation number 4, N2 by N1 plus 1 will be equal to this term plus 1. Same thing it has been written over here. N2 by N1 plus 1 is equal to this term plus 1. W1 into WP plus S32 plus S32 into WP by these two terms plus 1. That implies N2 plus N1 by N1 will be equal to this one. After simplification of this term, we can find this one. Then further simplification, we can find this one. W1 into WP, W1 plus S32 plus S32 WP, and so on by these two terms. Okay. That implies N2 plus N1 by N2 is equal to, here you can see, W1 into WP, one term, W1 into WP. So it will be 2 W1 WP, right? Written over here. Okay. W1 S32, W1 S32, W1 S32 here. So 2 W1 S32 written over here. Then another 3 terms written as such here. S32, S32, WP, and A21 WP, A21 S32. These 3 terms as such it has been written over here. Okay, okay. Divided by these 2 terms. That implies N2 plus N1 by N2 will be equal to here. From these 2 terms, 2 W1 taken common, so 2 W1 into WP plus S32 and other 3 terms written as such. Now by dividing equation number 6 with 5, that means 5 by 6. So this is the equation number 6 and this is your equation number 5. 5 by 6 means N2 minus N1 by N1. Here LHS of 6 is your N2 plus N1 by N1. That means N2 minus N1 by N1 by N2 plus N1 by N1. N1, N1 got cancelled. So we can find N2 minus N1 by N2 plus N1 likewise. Equation number 5 by 6, no? So this much value divided by RHS of equation number 6. So if I'll do so here, this denominator term is common for equation number 5 and 6. See, W1 A21 WP S32, W1 A21 WP S32. So they will be cancelled out and we can find numerator of equation number 5. This is the numerator of equation number 6. Okay. You can see numerator of equation number 5 is your S32 WP minus A21 WP minus A21 S32 written. Okay. By this much value. Numerator of equation number 6 written over here. Right. Here A21 is less than that of the S32. Hence A21 can be neglected. Now the above equation will be this much. Here A21 is less than that of the S32. Why? Which one is the A21? A21 is this one. Spontaneous emission radiative. This one. A21N1. And here this one is your S32N3. So this term is your actually S32N3. Here A21 is less than that of the A21 considered as less than that of the S32. So S21 will be neglected as compared with S32 for this equation. First of all, why it is considered as less than that of the S32? See, if I will consider this probability transition from 2 to 1, spontaneous transition from 2 to 1 is faster, or probability of transition from 2 to 1 spontaneously is faster than spontaneous transition from 3 to 2, then whatever the molecules or atoms will be here, they will be fastly transit faster to ground state as compared with E3 to E2. So if there is no atoms available in E2, then how we can get the population inversion? So to achieve the population inversion, here it is considered that A21 natural transition or spontaneous transition from E2 to E1 is negligible as compared with spontaneous transition from E3 to E2. Okay, so to maintain the population inversion between E2 to E1, here it is considered that this spontaneous transition is less as compared with this spontaneous transition, and this one is your radiative and this is your non-radiative, right? So if it is so, then we have to neglect this A21 as compared with S32. So this one, this term will be neglected, this term will be 0, and here this term also will be 0, right? This term could not be 0 because this is multiplied with S32, right? So this term and this term will be neglected. So we can found N2 minus N1 by N2 plus N1 is equal to S32 WP minus A21 S32. So taken common S32, we can found WP minus A21. In the denominator, we can found 2W1 into WP S32 plus this term plus this term, right? Okay. Now at the ledging action, that means when the ledging action will be started by the three level ledger system, at that time N3 is negligible as compared with N2. That means here it is considered as all the atoms whatever formed from E2 to E3, they all are came down to E2 by non-radiative transition, due to which we got the population inversion between E2 and E1. So at the ledging action, the ledging action will start when the population inversion will be created between E2 and E1. So the population inversion created means at E2 large number of atoms available as compared with E3. So obviously N3 is approximately 0 as compared with N2. So at the ledging action, total number of atoms in the system N1 plus N2 plus N3 equal to N will be equal to how much? At the ledging action, N3 is approximately 0 is equal to this total number of atom. At that time, if I am going to count, then it will be equal to N1 plus N2. Okay, that means at that time we are going to expect that most of the around, I can say 98 percentage, suppose just roughly I can say 90 percentage of atom will be here in E2, and around 8 percentage of atom will be here at E1, and only 2 percentage of atom will be at E3. So here if I'm going to add E2 to E2 and E1 number of atoms around 98 and 99 percentage. So total number of atoms and molecules is equal to N1 plus N2 when the ledging action start. Ledging action start by three level ledger system. So for ledger action, the population inversion should be positive. Okay, that means N1 minus N2 should be positive. This is possible if this term will be positive or greater than 0. So here N2 minus N1 by N2 plus N1 represents what? Represents the population inversion. Represents the population inversion between N2 and N1. So here N2 minus N1 by N2 plus N1, nothing but we can write N2 minus N1 by total number of atom, because total number of atom will be is equal to N2 plus N1 at the ledging action. That means the difference, the ratio between the difference of atoms or molecules between these two energy level with respect to total number of atoms or molecules in a three level ledger system. So this is represents the population inversion at the time of ledging action. Okay, because N2 plus N1 is nothing but itself N, total number of atom, because at the time of ledging action N3 is approximately 0. So here population inversion will be positive. How it will be positive? It will be positive when this numerator will be positive. The numerator will be positive when this WP will be greater than that of the A21. That means what? Pumping rate from level 1 to 3 This WP is represent the pumping rate from level 1 to 3 should be greater than that of the coefficient of radiative spontaneous emission from level 2 to level 1. Okay, so this is the condition for laser action or laser oscillation for 3-level laser system. This is the condition. So here we found that for a 3-level laser system, when pumping rate from level 1 to level 3 is greater than that of the radiative coefficient of radiative transition, sorry, spontaneous emission from level 2 to 1. Okay, so this is the spontaneous emission A, 2, 1, and 2. So when WP will be greater than that of the W to 1, at that time we can get the laser action or laser oscillation in a 3-level laser system, right? Now we are going to go for threshold pumping power. What will be the threshold pumping power? Okay, if in your exam this 3-level laser system asked find out the condition of laser action for a 3-level laser system, up to this much you have to write. Derivation, you can omit the derivation in your exam, but up to this much. Then this is a extra part, maybe it will be helpful for your numericals. Here then the number of atoms pumped from level 1 to 3 per unit volume per unit time will be equal to WP into N1, the so-called rate equation itself. Let the pumping frequency equal to H mu. Hence the power required per unit volume will be how much? This is the so-called rate equation into energy by considering this frequency. So WP into N1 into H mu P. So this is the power required per unit volume to pump the atoms from level 1 to 2 per unit volume per unit time, right? But the threshold condition is what? Threshold condition is WP should be greater than equal to A to 1. At that time we can get the laser action. That implies here instead of WP I can write A to 1 N1 H mu P for the laser action or the threshold condition of the laser action, or when the laser action starts. So instead of WP I can write A to 1, whatever we have been discussed in the previous, this one here. Okay, see, when WP just greater than equal to A to 1, then 3-level laser system will be give the laser action or laser oscillation. At that time it will start, right? Here when we are getting laser action, the population inversion is created between E2 to E1. Already we have been discussed. We know that at the time of lasing action N3 is approximately equal to 0, whatever I have been discussed over here. Therefore total number of atom at the time of lasing action, total number of atom is equivalent to N1 and N2. Remember this is the condition when the laser action starts. When the laser action starts, this is the condition. N3 is approximately 0. Whatever the total number of atoms will be available in these two energy levels. Now threshold condition for population inversion between E2 and E1 is N2 greater than equal to N1. When N2 just greater than that of the N1, then we can found the lasing action. So here you can see, if N2 will be equal to N1, from this equation N2 equal to N1 equal to N by 2. If I'm going to put N1 equal to N2 over here, then we can found what? 2N2 equal to N, N2 equal to N by 2. So by considering these two conditions, we can write N2 equal to N1 equal to N by 2 at just lasing action starts. That means at the threshold condition of laser action or lasing action, this is the value what we found, right? So this P value or power required per unit volume per unit time just at the laser action starts will be equal to A to 1. Instead of N1 we can write N by 2 H mu P, right? Here A21 is nothing but 1 by TSP, lifetime. This is the lifetime of energy level 2, spontaneous lifetime. So only for that it is written as SP. Already we have been discussed. A21 unit always second inverse. So this is nothing but is equal to 1 by lifetime of the level 2. So threshold pumping power is equal to this much. So this expression is most important for various numericals. You just remember this one. This is the expression of threshold pumping power. This is the spontaneous lifetime of this energy level, and this is the total number of atoms or molecules in three level laser system. H mu p is your what? Pumping energy. Okay. Okay. So here I am going to stop this lecture. In our next lecture, we are going to discuss rate equation of 4-level laser system. Okay. So thank you so much for watching this video. Thank you.